Good afternoon. My name is Ekaterina Bryanskaya, and my work is dedicated to brightness controller optimization for the Digital Diaphanoscopy System. The method of digital diaphanoscopy is used to diagnose inflammatory diseases of the maxillary sinuses. It consists in translucent maxillary sinuses by anatomically shaped LED applicator with two radiation sources, visualizing the scattering pattern of light by smooth camera, and the following digital processing of the obtained images by specialized software. Using the previously developed LED brightness controller, the necessary optical radiation power can be selected. Previously conducted studies revealed that in male, the maximum volume of the radiation power wasn't sufficient to obtain an adequate scattering pattern of light passing through the sinuses. It is related with their anatomical features. Thus, the aim of the study was to modernize the brightness controller in order to change the power radiation in a wider range and to determine the required power for the male diagnosis. To solve this problem, we conducted additional analysis and selected the necessary parameters of the device elements. Using a control panel and a photodiode sensor for the power meter, the values of the emitter optical power were measured at two wavelengths at different states of the controller. This is shown in the table. There are examples of the female and male studies with setting the values of the brightness controller from 1 to 250 units in increments of 50 units. It's noted that in female studies, the maxillary sinuses were well visualized at the controller value of 50 units and the camera exposure time value of 40 milliseconds. In the male study, the required power was equal to 250 units while increasing the value of the camera exposure time to 60 milliseconds. Based on the obtained data, future studies will be conducted on volunteers and patients with different body mass index. It will be also conducted a refined numerical simulation using the established radiation power values in order to establish medical and technical requirements. Thank you for your attention.